我的国语讲标准吗？ My face was cut because somebody was washing the knife. There are two fundamental things that are happening. Taiwan is the home of our treasured partners. This is, in fact, where everything NVIDIA does begins. Our partners and ourselves take it to the world. Taiwan and our partnership has created the world's AI infrastructure. These are really, really exciting times. A restart of our computer industry, an industry that you have forged, an industry that you have created, and now you're prepared for the next major journey. I love you guys. It's a new industrial revolution.
Got the whole crypto world going wild. Bonnie blockchain, she's the queen of the game. Stacking crypto like it's her claim to fame. If you want success, then take a look away.
如果你今天需要一点动力，那恭喜你点进这一支影片。黄仁勋在台大演讲的这一支影片呢，我们会省略很多技术层面的说明，而是专注在黄仁勋跟 NVIDIA 的大格局，还有台湾对产业链的重要性。如果想要看更多技术层面的解释呢，那他在这一支 GTC 大会影片里面就已经很清楚说明过。影片连结我会放在下面资讯栏，有空你可以回头找一下。这一支影片呢，其实网络上面已经有很多中文翻译了。我原本不想要再做一支整理，但是我看了，觉得大多数都是用这个翻译软体翻译，很多时候词不达意。我就觉得这种宝藏内容呢，如果没有完整表达，真的太可惜了。所以这一支影片呢，我亲自人工翻译啊，把情绪啊、文字枝微末节尽量讲清楚。为什么要做这一系列的黄仁勋演讲中文翻译呢？因为我也深深相信，未来不积极使用 AI 的人跟产业可能会被时代的潮流淘汰，所以我希望你也能听到这些内容。看完呢，你会对未来工作人生有更多更深刻的启发。贯穿影片的呢，是世界上最强的公司它待人处事的细节 ，AI 未来可以做到什么事情，还有黄仁勋对家乡还有产业链的感谢。没有一个人的成功是因为他很强，而是所有帮助他的人都很强，很强的一群人一起透过努力成就了伟大的故事。不管你身在什么产业里面，不管你现在人生位置是一个老板、高层还是员工，只要你在努力的路上，只要你内心有想要成功的种子，看完你都会非常有收获。以下是帮你制作的精华整理，希望你会喜欢。
All right, let's get started.
Good take, good take.
Oh, geez.
And cut. Okay, you guys ready?
Yeah.
Everybody thinks we make GPUs. NVIDIA is so much more than that. This whole keynote is going to be about that.
Okay, so we'll start at the top.
Examples of the use cases and then seeing it in action. That's kind of the flow.
It's such a compelling story. I'm super nervous about this.
Just gotta get in the rhythm.
We're 2 weeks away from it. You guys can go really, really make it great.
We should take a swing at it.
Yeah, that's the plan.
I think we need to get daily status on that animation.
Can you mute? Because I hear myself.
Sorry.
What's the drop date for all the videos?
It needs to be done on the 28th.
Did you get all that?
Safe travels, everybody.
Super excited to see everyone.
See you guys soon. Okay.
Bye.
We're basically moving as fast as the world can absorb technology, so we've got to leapfrog ourselves. Isn't it right? Now the spine, you just have to figure out a way to make it pop. You know what I'm saying? You know what I'm saying? You want to, yeah, that kind of thing. Thank you. I'm super late. Let's go.
NVIDIA 创办人暨执行长黄仁勋先生。
Please welcome to the stage NVIDIA founder and CEO Jensen Huang.
I am very happy to be back. Thank you, NTU, for letting us use your stadium. The last time I was here, I received a degree from NTU. And I gave the run, don't walk speech. And today we have a lot to cover. So I cannot walk, I must run. I'm very happy to be here in Taiwan. Taiwan is the home of our treasured partners. This is, in fact, where everything NVIDIA does begins. Our partners and ourselves take it to the world. Taiwan and our partnership has created the world's AI infrastructure. These are really, really exciting times. A restart of our computer industry, an industry that you have forged, an industry that you have created, and now you're prepared for the next major journey. I want to speak to you in Chinese, but I have so much to tell you, I have to think too hard to speak Chinese, so I have to speak to you in English. Two fundamental technologies, accelerated computing and artificial intelligence, running inside the omniverse. Those two technologies, those two fundamental forces of computing are going to reshape the computer industry. The computer industry is now some 60 years old. In a lot of ways, everything that we do today was invented the year after my birth, in 1964. All of the things that we know today about computing largely described in 1964. Of course, the PC revolution democratized computing and put it in the hands and the houses of everybody. And then in 2007, the iPhone introduced mobile computing and put the computer in our pocket. Ever since, everything is connected and running all the time through the mobile cloud. This last 60 years, we saw several, just several, not that many actually, 2 or 3 major technology shifts, 2 or 3 tectonic shifts in computing, where everything changed. And we're about to see that happen again. There are 2 fundamental things that are happening. The first is that the processor, the engine by which the computer industry runs on, the central processing unit, the performance scaling has slowed tremendously. And yet, the amount of computation we have to do is still doubling very quickly, exponentially. If processing requirement, if the data that we need to process continues to scale exponentially, but performance does not, we will experience computation inflation. And in fact, we're seeing that right now as we speak. The amount of data center power that's used all over the world is growing quite substantially. The cost of computing is growing. We are seeing computation inflation. This, of course, cannot continue. The data is going to continue to increase exponentially, and CPU performance scaling will never return. There is a better way. For almost 2 decades now, we've been working on accelerated computing. Just last week, Google announced that they've put cuDF in the cloud and accelerate Pandas. Pandas is the most popular data science library in the world. Many of you in here probably already use Pandas. It's used by 10 million data scientists in the world. Downloaded 170 million times each month. It is the Excel, it is the spreadsheet of data scientists. Well, with just one click, the speed up is really incredible. Let's take a look. That was a great demo, right? Didn't take long. Is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
想象一个我们能够预测未来的世界，数位孪生反映真实情况的虚拟世界，让我们看见未来。数位孪生是一种反映真实世界的虚拟模型，让我们能够从今天的行为来预测对未来世界的影响。介绍一下 NVIDIA Earth 2，一个利用 AI、物理模拟和电脑图形技术来预测全球气候的数位孪生。 COMPUTEX 是 NVIDIA 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练而成，能够以12倍更高的解析度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，COMPUTEX AI 比传统的物理模拟方法快1000倍，且能源效率高3000倍。在台湾的中央气象局是用这些模型来更精确地预测台风登陆点。但我们并不止步于此，下一个前沿是超本地预测，能精确到数十米，并考虑到城市基础设施的影响。COMPUTEX AI 还在使用像是 PaLM 生成的高解析度数据进行训练，一个极高解析度的物理模型，用于模拟大气和海洋边界层。当与天气模拟风场结合一起时，它可以模拟建筑物周围的气流。单极强风汇聚的情况，我们预计能够预测像下冲这样的现象。当强风汇聚到街道层，会有可能造成损坏并影响行人。NVIDIA Earth 2是一个绝佳范例，它融合了人工智慧、物理模拟和观测数据，可以帮助国家和公司预见未来，并应对极端天气的影响。
我的国语讲的标准吗？The truth is, that was a Jensen AI. That was not me. We dedicated ourselves to reinvent everything. That was 10 years ago now. And all of it came together on a brand new computer nobody understood. Nobody asked for it. Nobody understood it. And in fact, I was certain nobody wanted to buy it. And so we announced it at GTC. And OpenAI, a small company in San Francisco, saw it. And they asked me to deliver one to them. I delivered the first DGX, the world's first AI supercomputer, to OpenAI in 2016. And then in November 2022, trained on thousands, tens of thousands of NVIDIA GPUs in a very large AI supercomputer, OpenAI announced ChatGPT. 1 million users after 5 days. 1 million after 5 days, 100 million after 2 months. The fastest growing application in history. And the reason for that is very simple. It is just so easy to use, and it was so magical to use. To be able to interact with a computer like it's human, instead of being clear about what you want. It's like the computer understands your meaning. It understands your intention. Oh, I think here it asked the closest night market. As you know, the night market is very important to me. So when I was young, I think I was 4.5 years old. I used to love going to the night market because I just love watching people. And so we went, my parents used to take us to the night market. 圆环，讲对吗？圆环，去吃蚵仔煎。And I love going. And one day, my face, you guys might see that I have a large scar on my face. My face was cut because somebody was washing their knife, and I was a little kid. But my memories of the night market is so deep because of that. And I used to love, I still love going to the night market. And I just need to tell you guys this. The Tonghua night market is really good because there's a lady, she's been working there for 43 years. She's the fruit lady, and it's in the middle of the street, the middle between the two. Go find her, okay? She, 做赞的，在喝价。She's really terrific. I think it would be funny after this, all of you go to see her. Every year she's doing better and better. Her cart has improved, and yeah, I just love watching her succeed. Anyways, Anyways, ChatGPT came along. Until ChatGPT revealed it to the world, AI was all about perception, natural language understanding, computer vision, speech recognition. It's all about perception and detection. This was the first time the world saw a generative AI. It produced tokens, one token at a time. And those tokens were words. Some of the tokens, of course, could now be images or charts or tables, songs, words, speech, videos. Those tokens could be anything. Anything that you can learn the meaning of. It could be tokens of chemicals, tokens of proteins, genes. You saw earlier in Earth 2, we were generating tokens of the weather. We can use this method to generate tokens for almost anything of value. We can generate steering wheel control for a car. We can generate articulation for a robotic arm. Everything that we can learn, we can now generate. We have now arrived not at the AI era, but a generative AI era. But what's really important is this. This computer that started out as a supercomputer has now evolved into a data center, and it produces one thing. It produces tokens. It's an AI factory. This AI factory is generating, creating, producing something of great value, a new commodity. In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry. Not a manufacturing industry of computers, but using the computers in manufacturing. This has never happened before. Quite an extraordinary thing. What started with accelerated computing, led to AI, led to generative AI, and now an industrial revolution. One of the most important applications in the coming future, of course, is customer service agents. Customer service agents are necessary in just about every single industry. It represents trillions of dollars of customer service around the world. Nurses are customer service agents in some ways. Some of them are non-prescription or non-diagnostics based nurses are essentially customer service. Customer service for retail, for quick service foods, financial services, insurance, just tens and tens of millions of customer service can now be augmented by language models and augmented by AI. And so these boxes that you see are basically NIMs. Some of the NIMs are reasoning agents. Given a task, figure out what the mission is, break it down into a plan. Some of the NIMs retrieve information. Some of the NIMs might go and do search. So all of these NIMs are experts that are now assembled as a team. So what's happening? The application layer has been changed. What used to be applications written with instructions are now applications that are assembling teams of AIs. Very few people know how to write programs. Almost everybody knows how to break down a problem and assemble teams. Every company, I believe in the future, will have a large collection of NIMs, and you would bring down the experts that you want. You connect them into a team, and you don't even have to figure out exactly how to connect them. You just give the mission to an agent, to a NIM, to figure out who to break the tasks down and who to give it to. And that central, the leader of the application, if you will, the leader of the team, would break down the task and give it to the various team members. The team members would perform their task, bring it back to the team leader. The team leader would reason about that and present an information back to you. Just like humans.
Great to be in Taiwan. Before I head out to the night market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
they will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
We have generated several design options for you to choose from.
There'll also be AI customer service agents, making the interaction more engaging and personalized, or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And there'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models, built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. NVIDIA ACE is a suite of digital human technologies packaged as easy-to-deploy, fully optimized microservices or NIMs. Developers can integrate ACE NIMs into their existing frameworks, engines, and digital human experiences. Nemotron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva Speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMs run on NVIDIA GDN, a global network of NVIDIA accelerated infrastructure that delivers low-latency digital human processing to over 100 regions.
Every single time data generation grows, the amount of computation that we have to offer needs to grow with it. We are about to enter a phase where AIs can learn the laws of physics and understand and be grounded in physical world data. And so we expect that models will continue to grow, and we need larger GPUs. Well, Blackwell was designed for this generation. This is Blackwell, and has several very important technologies. One, of course, is just the size of the chip. We took two of the largest, a chip that is as large as you can make it at TSMC, and we connected two of them together. Ladies and gentlemen, this is Blackwell. Blackwell is in production. Incredible amounts of technology. This is the MGX system, and here's the two Blackwell boards. So this one node has 4 Blackwell chips. Let me talk about what's next. The next wave of AI is physical AI. AI that understands the laws of physics, AI that can work among us. And so they have to understand the world model so that they understand how to interpret the world, how to perceive the world. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks. In the future, robotics is a much more pervasive idea. Of course, when I say robotics, there's a humanoid robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them and plan how they'll act. And from human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills. One of the integral technologies for advancing robotics is reinforcement learning. Just as LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated world. These simulation environments are where robots learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms, a robot can learn to perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built NVIDIA Omniverse as the operating system where physical AIs can be created. Omniverse is a development platform for virtual world simulation, combining real-time, physically based rendering, physics simulation, and generative AI technologies. In Omniverse, robots can learn how to be robots. They learn how to autonomously manipulate objects with precision, such as grasping and handling objects, or navigate environments autonomously, finding optimal paths while avoiding obstacles and hazards. Learning in Omniverse minimizes the sim-to-real gap and maximizes the transfer of learned behavior. Building robots with generative physical AI requires 3 computers: NVIDIA AI supercomputers to train the models, NVIDIA Jetson Orin and next-generation Jetson Thor robotic supercomputer to run the models, and NVIDIA Omniverse, where robots can learn and refine their skills in simulated worlds. We build the platforms, acceleration libraries, and AI models needed by developers and companies, and allow them to use any or all of the stacks that suit them best. The next wave of AI is here. Robotics, powered by physical AI, will revolutionize industries.
This is happening all over Taiwan. Foxconn is building digital twins of their factories. Delta is building digital twins of their factories. By the way, half is real, half is digital, half is Omniverse. Pegatron is building digital twins of their robotic factories. Wistron is building digital twins of their robotic factories. And this is really cool. This is a video of Foxconn's new factory. Let's take a look.
Foxconn, the world's largest electronics manufacturer, is gearing up to meet this demand by building robotic factories with NVIDIA Omniverse and AI. Factory planners use Omniverse to integrate facility and equipment data from leading industry applications like Siemens Teamcenter X and Autodesk Revit. In the digital twin, they optimize floor layout and line configurations and locate optimal camera placements to monitor future operations with NVIDIA Metropolis-powered Vision AI. Virtual integration saves planners on the enormous cost of physical change orders. During construction, the Foxconn teams use the digital twin as the source of truth to communicate and validate accurate equipment layout. The Omniverse digital twin is also the robot gym, where Foxconn developers train and test NVIDIA Isaac AI applications for robotic perception and manipulation, and Metropolis AI applications for sensor fusion. In Omniverse, Foxconn simulates 2 robot AIs before deploying runtimes to Jetson computers. On the assembly line, they simulate Isaac manipulator libraries and AI models for automated optical inspection for object identification, defect detection, and trajectory planning. To transfer HGX systems to the test pods, they simulate Isaac Perceptor-powered Ferrobot AMRs as they perceive and move about their environment with 3D mapping and reconstruction. With Omniverse, Foxconn builds their robotic factories that orchestrate robots running on NVIDIA Isaac to build NVIDIA AI supercomputers, which in turn train Foxconn's robots.
Taiwan builds computers with keyboards. You build computers for your pocket. You build computers for data centers in the cloud. In the future, you're going to build computers that walk and computers that roll, around. And so these are all just computers. And as it turns out, the technology is very similar to the technology of building all of the other computers that you already built today. So this is going to be a really extraordinary journey for us. Well, I've made one last video, if you don't mind.
台湾帮助我们实现了一个愿景，在这条漫长的路上，无数的伙伴支持着我们，从加速运算、电脑绘图、科学研究到人工智慧的高峰，每一个晶片、每一台电脑，都描写着你们辛勤工作和追求完美的故事。台湾是无名的英雄，却是世界的支柱。一起，我们推动了产业的复兴，辛勤的耕耘，让我们能够踏入崭新运算的领域。其中，我们制作的电脑会转化成新型的工厂，制造珍贵无比的人工智慧。亲爱的伙伴们，你们是 AI 产业革新的后盾。无论面对多大的风浪，你始终稳如磐石。科技的卓越、勤奋与齐心合力的精神，是你的超能力。没有你，我们的愿景只是一个无法实现的梦想。与你同行，我们勇往直前。创造智慧与便利的生活，对抗疾病和自然灾害，让我们的世界变得更美好。谢谢你，台湾。让我们继续为这段 AI 创新之旅，打造一个成功和繁荣的产业。
大家谢谢 ，Thank you. I love you guys. Thank you.